In this presentation, we will review the different levels of measurement. This slide will be helpful when you design a survey later in the semester. As you now know, there are 4 levels of measurement: nominal, ordinal, interval, and ratio. So as you move from nominal to ratio, each level provides additional information for that variable, and so a better way to compare findings. Here's a good moment to review 2 past concepts that are relevant for levels of measurement: the unit of analysis and variables. If you remember, the unit of analysis are the entities being studied, and a variable is a concept being measured to see if there's variation across individual entities. So for example, in Dr. Bro's research, her unit of analysis was students, and the variables were sports participation and academic achievement. So she was looking for variation in those 2 variables from one student to another. Okay, let's return to our levels of measurement. Here's a table explaining the different information that's provided by the 4 levels of measurement. Nominal allows for classification, the ordinal allows for classification and rank order, and we see here that ratio all the way at the end offers the most flexibility as it provides us with all 4 different types of information. So the variable that you have will determine the level of measurement that you can use. But whenever possible, if you're able to use the most flexible variable, ratio, you should always try to go with that one. So in Dr. Bro's research, the variable sports participation was likely a nominal variable. So a question asking, do you participate in sports? Yes or no. So 2 categories, 2 classifications. While academic achievement, the other variable, I imagine it was probably a ratio variable, such as asking, what is your GPA? And the answer would be a number, which is a ratio. Let's look at a few other examples, and then we'll return to this table at the end of the presentation. So here's one example of how to measure income. This is an ordinal level of measurement. We have the different categories, and they are in rank order. So for categories, we can categorize people into the different options depending on how much income they earn a year. So this fulfills the classify criterion from the previous slide. Furthermore, someone who chooses number 3 earns more than someone who chooses number 2. This fulfills the rank order in the previous slide. However, if 2 people choose number 3, but they earn different amounts of money in a year, we would not be able to tell which of them earns more than the other using this level of measurement. However, the ratio can. Here is an example of income seen as a ratio level of measurement. So based on this hypothetical data, we can tell that a 30-year-old earns, or 30-year-olds earn 60% of what 40-year-olds earn. We would not have been able to arrive at this conclusion using any other level of measurement, because with a ratio level of measurement, we have an absolute 0, and so we can multiply and divide, creating percentages. So let's look at some more examples. Let's look at 4 variables that represent the 4 different levels of measurement: age, temperature, stage of medical study, and region. First, let's look at age. Age is a ratio level variable, meaning there is equal distance between numbers. So 1, 2, 3, 4, and so on. And it has an absolute 0, allowing us to compute ratios or percentages. So how old are you and how old am I? Let's assume that you're 20 and I am 40 years old. What distinct conclusions can be drawn when we compare our variables of age? For example, we can infer or conclude that we have different ages. We can also infer that I am older than the student. I am 20 years older than the student, and that I am twice as old as the student. Finally, the term ratio comes from this last conclusion, number 4. I am twice as old as the student, so the ratio of ages is 2 to 1. Let's take a look at the next variable, temperature. Temperature is an interval scale variable, so let's assume that you have a normal body temperature, but I'm feeling a bit feverish and have a high temperature of 100. What can we infer from this variable? First, we have different temperatures, so classification. My temperature is higher than the student, rank order. My temperature is 1.4 degrees higher than the student, but we cannot say that my temperature is 100 over 98.6 times higher than the student because we don't have an absolute zero. So this is the major difference between a ratio variable and an interval scale variable. While they're both numbers, only the ratio variable has an absolute zero. Temperature does not have an absolute zero because it's an arbitrary zero. If you are at 0 Celsius, this does not mean that you have no temperature. It just signifies a temperature point on the scale, freezing. However, if you have 0 income, that is an actual zero. And so if you don't understand the difference between these two, don't worry about it too much because we don't often use interval scale variables. But I just included it here so that we can understand the importance of ratio variables. Now let's look at the next variable, stage of medical study. So the different stages that a student wishing to become a doctor goes through include pre-medical student, medical student, intern, and resident. So this is an ordinal scale variable because there's a rank order. You go from lower to higher. So what can we infer from this variable? Let's say Tom is a medical student and Lisa is an intern, meaning that she has her medical degree but she's not yet licensed. So we can infer that they are at different stages, classification. Lisa is more advanced than Tom, rank order. But we cannot say how much more advanced Lisa is than Tom. Tom might be a month away from graduating, or maybe he just started medical school. We also cannot infer a ratio difference. For example, Lisa is a certain percentage more advanced in her studies than Tom. So ordinal scale variables can be very useful in surveys, and you all have probably seen them in the student evaluations you fill out at the end of the semester, ranking an instructor's teaching effectiveness. Here are some other examples of ordinal variables. So now let's look at the last variable, region. So for example, where were you raised? This is a nominal scale variable. Let's say that you were raised in the Northeast and I was raised in the Southeast. What can we infer from this variable? We are from different regions, but we cannot rank differences between us. There are no equal intervals, and there's no absolute zero, so we cannot infer numerical differences between us. So let's review the table that we saw at the beginning of the presentation. A nominal level of measurement, such as region, allows for classification. Ordinal, which was the stage of study or the degree to which you agree with a statement. This allows for classification and rank order. The interval, which was the temperature example, offers both of these plus the interval. so we can compute some numerical inferences, not all. In the ratio, the last one, which was, or rather, was the first example I gave you of age, it offers the most flexibility when comparing information, so we can compute ratio differences or percentages. Now you know the different levels of measurement and the information that each provides for various variables. When creating a survey in the next few weeks, it'll be important to remember these levels, especially nominal, ordinal, and ratio, and to be able to choose the one with the most flexibility, if possible. So this is the end of the presentation. You can continue to the next module item and exercise to practice your knowledge of levels of measurement.